Okay, so this is the last of our statistics videos, and we're looking at sampling distributions. So a little bit of the story here, we're not going to do this whole page, but you kind of need to know what's going on for the next page. So Paul the Octopus was a famous octopus known for predicting the outcomes of soccer matches. He lived in a German aquarium and was presented with 2 boxes containing food, each marked with the flags of competing teams. Paul would choose a box, and his choice was interpreted as a prediction. During the 2010 FIFA World Cup, Paul attempted to predict 8 matches in the tournament. We are going to see how likely it would be for Paul to predict 8 out of 8 matches by creating a distribution of sampler proportions. So we're not going to create all this. We're going to look at this information on the next page, and we'll come back to, was this very likely to happen or not? All right, so a simulation is a way to model a real-world situation by repeating a random process many times and observing the results. Helps us understand how likely different outcomes are without having to collect real data repeatedly. So it's just a simulation. It just keeps doing it over and over and over again so that we can get lots of data there. This one shows 8 tosses of a fair coin repeated 500 times. This will allow us to determine if guessing 8 out of 8 games correctly is unusual. So what we're looking at here is our 95% confidence interval centered around the mean. Now, we talked about this with the normal distribution curve where it has to do with within 2 standard deviation. We have a 95% confidence that data would fall in that range. So just a little bit of vocabulary. The lower bound is the mean minus our 2 standard deviations, and our upper bound is the mean plus our 2 standard deviations. So if what we're talking about falls within the range, then it's likely, plausible, usual. Any of those words might be used. If it's outside, it's considered unlikely or unusual. So we want to find that middle 95% based on the information that we're given here. Now, this graph looks kind of confusing. Maybe we've seen a lot of these if you flipped through some old Regents or anything like that, and they do show up a lot. But what's actually very key is looking for this little box that they tend to put either in the upper left or upper right-hand corner. So to find our middle 95%, that's our mean plus minus 2 of our standard deviations. So if we want to do that for this problem, that's 0.497 plus and minus 2 of our standard deviation, so 0.17. Now we can't do the plus and the minus at the same time in our calculator. We have to do them separately. All right, but when we do the minus, we get 0.157, and the plus, we end up with 0.837. So we would say that 95% of the data is going to fall between these two things. And in this case, it's talking about percentages. So between 16% and 84% here, that's where we can say that we're pretty confident here. So during the 2010 World Cup, Paul the Octopus correctly predicted 8 out of 8 matches. Based on this simulation, is it unusual that he guessed 8 out of 8 matches correctly? Well, we need to turn that 8 out of 8 into a decimal so we can see if it fits into that confidence interval or not. Well, 8 out of 8 is 1.0 if you want. All right, but that does not fall within here. And I mean, I think we could all probably say with confidence that guessing everything correctly is unlikely. Statistically, it's also unlikely because it does not fall within this 95%. So based on the simulation, is it unusual? And the answer is yes. And we would say because 1 does not fall within the 95% confidence interval. So we're going to look more at this confidence interval as we keep going. That's pretty much what this whole video is going to be about. All right, so let's look at our next page here, page 65. And so we have this thing that we call the margin of error. Now, we've already looked at the margin of error. You just didn't know that's what it was called. But the margin of error is 2 times our standard deviation. So that part that we add and subtract to the mean to find our 95% confidence interval, that part, the 2 times the standard deviation, we call a margin of error. sometimes abbreviated as MOE. Now, we're not going to do this piece here. All right, that's not usually how it's asked on the Regents exam. I don't know if it's ever been asked that way, but we don't usually go through that whole process. We stick with the 2 times the standard deviation. So looking here, we're looking at this whole sample here, and it just wants to know what is the margin of error for the simulation. Now, there's a whole lot of reading up here that you should definitely do if it's a test, a quiz, anything like that. But a lot of times with these problems, again, the relevant information is found in this little box here. So if I want the margin of error, I just want 2 times the standard deviation. Now, 2 times 0.05 is 0.01. So that's my margin of error. So nothing too complicated. Sometimes a lot of the words get in the way and actually make it seem more complicated than it really is. All right. We're not going to do this top one that has to do with that piece of information that we are not going to work through at this point. Like I said, not likely that it's going to be asked. All right, so again, a whole lot of data that's going on. Simulation results in a mean of 0.104 and a standard deviation of 0.037. Based on this simulation, what is a plausible interval containing the middle 95%? So middle 95 is what I'm looking for. I need mean and standard deviation. So 0.104 plus and minus 2 of the standard deviations. Now you can do that in your calculator. Again, you have to do the plus and the minus separately in order to get those 2 different numbers there. But what we end up with here is this one right here, choice 2. All right, keep going. All right. We're going to read this one because it's about coffee, and you know how I feel about coffee. Can't skip that. Coffee shop receives a shipment of 25 bags of ground coffee from a supplier. The average weight of the 25 bags is 11.75 pounds. The supplier claims that their bags of ground coffee have a mean weight of 12 pounds. To investigate, the coffee shop runs a simulation of 3,000 samples, each of 25 bags, assuming the supplier's claim of a 12-pound mean is true. The results of the simulation are shown below. Is the mean weight of the coffee shop sample unusual? Explain using the results of simulation. So whenever it's asking about is it unusual or not, you want your middle 95%. So our mean, which is 12, they didn't put it in a little box, but it's still up here on the graph here, plus minus 2 of our standard deviations. Now it's always 2 to get to that 95%. So when we do that, we end up with 11.8 sorry, I can't read my own handwriting here. Let me calculate again. All right, 12 plus 2 times 0.057, and that gives me the top one. Oh, you can't see that, sorry. It's very light. There we go. And then I can do the minus one as well. There we go. 11.886 is the lower one, and 12.114 is the higher one. Now we want to know if the coffee shop sample is unusual. So we have to go back up and figure out what the coffee shop sample is. They said that the average weight of their bags was 11.75 pounds. And so based on this, is that unusual? The answer is yes. It falls outside. 11.75 is less than the lower end here of the 95% confidence interval. Now we probably should be more specific. Instead of saying it, maybe we should say 11.75 falls outside of the 95% confidence interval. All right, more of this. So again, it's just going back to deciding whether the claim is valid or fair, unusual or usual, that kind of thing. These are worded a little differently, different times on the Regents exam, and sometimes you have to read the question really carefully to make sure you're answering it exactly the question that they asked. So here, again, huge simulation going on. it wants to know, is the claim that members work out an average of 5 hours per week plausible? So first, I should probably read this one a little more, make sure I know what's going on. A gym claims that an average number of hours per week that its members work out is 5. The gym conducted a survey of 300 of their members. The sample statistics are shown below. So this just means mean. It's another symbol for mean. We've used X with a bar. We've used this little U-shaped thing. And then SX also means standard deviation. So just different notation, same information. All right, so keep that in mind. A simulation was run 1,000 times based on the results of the survey. The results of the simulation are shown below. All right, so this is the simulation. It says based on the simulation results, so we want this stuff. Is the claim that members work out an average of 5 hours per week plausible? Explain your response, including an interval containing the middle 95% of the data, rounded to the nearest hundredth. So we take our simulation mean. This was a survey mean up here at the top. This is the simulation one. So again, read carefully. Plus minus 2 times the standard deviation. That's going to get us our middle 95 here. All right, so that ends up with, rounded to the nearest hundredth, 4.53 and 5.12. So then we want to know, is an average of 5 hours per week plausible? Well, it falls between here. So yes, 5 falls within the 95% confidence interval, which was 4.53 to 5.12. And it said to include an interval containing the middle 95%. So I had to make sure that I wrote that down in my explanation here. You could show it as interval notation as well. It doesn't matter there. But make sure you answer the question that's being asked. Don't get distracted by information you don't need. And then make sure that you're answering it completely. All right. We want to know, determine an interval containing the middle 95% of plausible values that estimates the proportion of all customers who would purchase both regular and diet sodas from the company. All right, so this is talking about that. So this is the information we're going to need. Determine an interval. So again, the mean plus minus 2 standard deviations. And we end up with, it didn't tell us what to round to, so I'll just go with the whole number here, the entire number, I should say. Okay. Next question. The company will continue to produce both types of soda if it is reasonable to assume that the true proportion of customers who buy both types of soda is above 0.75. Using the interval from Part A, explain whether or not the company should continue to produce both types of soda. So they're saying they'll produce them both if it's typical to get over 0.75. Well, 0.75 isn't in the interval at all, not to mention over that. So explain whether or not the company should continue. No. The company should not continue to produce both types because 0.75 is above the 95% confidence interval. Now you could have said outside of the 95% confidence interval. I said above, that way it's clear that we're not going to get above 75 in that interval either. 75 itself is above already. All right. Let's see, I think we got 2 more. All right, here, John had a 6-sided die. He does not know if it is a fair die. He rolled the die 100 times. Rolls are shown below. 17 times he got a 1, 15 times he got a 2, etc. John ran a computer simulation 200 times of 100 fair die rolls. The output of the proportion of rolling a 4 is shown below. All right, so out of all the simulation, this is the outputs for proportion of 4s. John feels the die may be unfair due to the high proportion of 4s he rolled. He rolled 23 4s out of all of his that he did, so he feels like maybe his die was unfair. So state the proportion of 4s that were rolled. Well, he rolled 23 out of, it says he rolled it 100 times. So 23 out of 100. Do the results of the simulation provide strong evidence that John's die is unfair? Explain your answer. So anytime you're trying to make those decisions, you want the 95% confidence interval. So our mean plus minus 2 of our standard deviation. Now that gives us 0.087 to 0.247. So we kind of need to know what this is as a decimal. Well, 23 out of 100 is 0.23. So is John's die unfair? Well, 0.23 falls within the 95%. So that means it's likely, it's expected, it's usual, so it's not unfair. So no, 0.23 falls in the 95% confidence interval. That means his results are expected or likely. So not difficult questions. Again, they look overwhelming just looking at all of the information that might show up in a problem, but just break it down little piece by piece. And like I said, most of the time, see this info right here. That's what we're going to need. So again, I'm kind of skipping up top to begin with because I just know it's distracting for me. So using the simulation results, so that's this here, construct a plausible interval containing the middle 95%. Round your answers to the nearest hundredth. So at this point, hopefully we're almost a little sick of doing the same thing. And this one gives me 0.64 to 0.76. 1 year after launching the company, the environmental department conducts a survey of 200 randomly selected city residents and finds that 130 of them still use plastic bottles. Should the department conclude that the city's campaign was effective, use statistical evidence for the simulation to explain your answer. Well, 130 out of 200, and we kind of need to know what that gives us. That gives us 0.65. Well, 0.65 is still inside this plausible, this likely events, and that's for people who are using the plastic bottles still. And they're trying to get them to use the recyclable bottles, and which you might understand if I had read more up here. So sometimes this is important. You do need to go back and read it, all right? But we want to know, is their campaign to get them getting rid of the plastic bottles effective? No. So no, 0.65 is still within the 95% confidence interval of people using plastic bottles. So we would want to get below that at this point to say, hey, our campaign's working. Now the percentage we're getting is beyond outside. It's lower than the percentage we had before of people still using those plastic water bottles. All right. Hopefully that made some sense to you. Hopefully you can let me know if you have any questions when we go over this tomorrow. But last video for statistics, so we can celebrate that.